Hare Krishna. This is my 12th video, and again in this session also I am going to continue, that is the derivative of a implicit function part 2. Before we have taken the 5 bunches, isn't it? And I have explained what do you mean by the implicit function. Now again I will give the more bunches to you and continue the derivative of a implicit function. So the next, that is the 6th bunch, here is, suppose y is equal to f of x plus 1 upon f of x plus 1 upon f of x plus 1 upon f of x dash dash. Again y is equal to, here you can write tan x plus 1 upon tan x plus 1 upon tan x dash dash dash. Y is equal to cos 4x plus 1 upon cos 4x plus 1 upon cos 4x, again dash dash dash. Y is equal to sin root x plus 1 upon sin root x plus 1 upon sin root x dash, and again log x plus 1 upon log x plus 1 upon log x. Now see, again you have to remember the procedure only. See, here again the first problem, that is y is equal to f of x plus f of x 1 upon f of x plus 1 upon f of x plus 1 upon f of x, isn't it? Now again if you observe this f of x remain as it is, and this is all, it is nothing but what is 1. This is 1 by y, f of x plus 1 upon f of x plus 1 upon f of x, right? Now again differentiate with respect to x. The derivative of a y, that is dy by dx. The derivative of a f of x, that is f dash x. And here minus 1 upon y square into dy by dx. Now collect the terms of dy by dx. Dy by dx plus 1 upon y square dy by dx, it is equal to f dash x, right? Again dy by dx you can take common. What is remain? 1 plus 1 upon y square. Here again this is f dash x. Therefore dy divided by dx into y square plus 1 divided by y square, it is equal to f dash x, isn't it? Therefore dy by dx, it is nothing but f dash x into y square divided by y square plus 1, right? So this is about the 6th bunch, isn't it? So again remember this bunch, and if you try to remember this, it is easy for the CET, isn't it? And also any entrance examination. Now the next here, that is the 7th bunch. See, 7th one. Here x square y square is equal to tan inverse root x plus cot inverse root x cube y cube sin inverse root of x square plus 1 cos inverse root of x square plus 1, isn't it? X to the power 4 y to the power 4. This is again sec inverse of x cube plus 1 cosec inverse of x cube plus 1. Now see, the result is dy by dx. It is nothing but minus y by x. Right. Again very simple. If you see the right hand side, it is nothing but what here pi by 2, because you know tan inverse x plus cot inverse x, it is always equal to pi by 2. Sin inverse x plus cos inverse x also equal to pi by 2, and you know sec inverse x plus cosec inverse x, it is equal to pi by 2, right? Now again if you see the right hand side, the root x, here also root x, the angle is same, you can directly write the result tan inverse root x plus cot inverse root x, it is nothing but pi by 2. Sin inverse root of x square plus 1 plus cos inverse root of x square plus 1. It is nothing but pi by 2. And sec inverse of x cube plus 1 plus cosec inverse of x cube plus 1. It is also equal to pi by 2. Therefore, simply you can write x square plus y square. It is equal to pi by 2. Now differentiate. Differentiate with respect to x. Right? Now x square remain as it is. Again here you have to apply the multiplication rule. So ddx of y square plus y square remain as it is, ddx of x square, and the derivative of a pi by 2, that is always equal to 0. Again x square remain as it is. The derivative with respect to x, and your function it is of a y. As usual you have to find out the derivative 2y. Take y from here, take x from here, and multiply with dy by dx. Again y square remain as it is. The derivative of x square, that is equal to 2x, isn't it? It is equal to 0, right? So again, what can you do? 2y x square into dy by dx. It is equal to minus 2x y square, right? Now 2 to get cancelled. Here you have got dy by dx. It is nothing but minus xy square divided by y x square. Again, one x get cancelled, one y get cancelled. See the result, that is minus y by x, isn't it? So this is the seventh bunch. Again, very simple here. X square y square, it is equal to this tan inverse root x plus cot inverse root x, and the right hand side, that is nothing but what here, pi by 2, because these are the formulas, that is the formulas of a inverse. So this is about the seventh bunch, right? Now I will take the eighth bunch. See, eighth one, e raised to x plus e raised to y. It is equal to e raised to x plus 1. A raised to x plus a raised to y. It is equal to a raised to x plus y. Again, 3 raised to x plus 3 raised to y. It is equal to 3 raised to x plus y. Right? Now, you can take any here. That is 4 raised to x plus 4 raised to y. It is equal to 4 raised to x plus y. The answer of the first here, see, that is nothing but dy by dx. It is equal to minus e raised to power minus e raised to power y minus x. Similarly, the second answer also, this is the first. Second answer also minus a to the power y by x. Third what here? Minus 3 to the power y minus x. Fourth what here? Minus 4 to the power y minus x. Right? These are the answers of this question here. That is the eighth bunch. Again, very simple. See here, e raised to x plus e raised to y. It is equal to e raised to x plus 1. Now differentiate with respect to x. Right? Now the derivative of e raised to x, that is e raised to x. The derivative of e raised to y, that is equal to e raised to y into dy by dx. Here again, the derivative of e raised to x plus 1, e raised to x plus 1. Here the derivative of x1, the derivative of y, that is dy by dx. Right? Now e raised to x plus e raised to y into dy by dx. Multiply with this term and open the bracket. Here e raised to x plus y plus e raised to x plus y into dy by dx. Right? Now again, collect the terms of dy by dx. Here the coefficient is e to the power y. Here the coefficient is e to the power x plus y. If you transfer this, you will get e to the power x plus y into dy by dx. And here again, e raised to x plus y. Transfer this term, minus e raised to x dy by dx. It is equal to e raised to x plus y minus e raised to x divided by e raised to y minus e raised to x plus y. Right? Now you can substitute here, see, to get that answer. This is also one of the answer, isn't it? This is, you can say, one of the answer, but we want what here? This answer. Therefore, you can substitute e to the power x plus y. It is nothing but what here? E to the power x plus e to the power y. Here you can substitute e raised to x, e raised to y minus e raised to x, and here again e raised to x plus e raised to y. Right? Now this term get cancelled. E raised to y. Here again multiply with minus sign and open the bracket. Right? E raised to y. Again e raised to y get cancelled. Again this minus remain as it is. And if you take this term in the numerator, you know the base is same. e raised to y divided by e raised to x. If you take in the numerator, the index get negative, isn't it? Therefore, here you have got e to the power y minus x, right? Similarly, this is one result, this is second result. Another result also you will get here, e raised to x plus y. This you can write as a e raised to x into e raised to y and minus e raised to x, isn't it? When the base is same, you can add indices. Here also same, e raised to x plus y you can write as a e raised to x into e raised to y. From the numerator, you can take e raised to x common, e raised to y minus 1. From the denominator, e raised to y common, 1 minus e raised to x. Right? Again, you can take in the numerator and you have got e to the power x minus y in bracket e raised to y minus 1 divided by 1 minus e raised to x. Right? Therefore, how many results are there? This is one. This is second that we want, and this is also the third result, isn't it? This is the third result. So, any result they can ask in the CET, isn't it? In the entrance examination. Therefore, this is the 8th one and it is very simple, isn't it? Again, the 9th one, see. 9th one, x raised to n, y raised to n, x plus y whole to the power n plus n. Right? Again, x cube, y to the power 4 is equal to x plus y whole to the power 7. Again, x square, y to the power 5, y to the power 3, suppose, x plus y whole to the power 5. Right? Again, you can write x to the power 4, y to the power 6. It is x plus y whole to the power 10. Right? Now, the result is here again, dy by dx. It is equal to y by x. See, this is again very, very important here. Now, x raised to m, y raised to n is equal to x plus y whole to the power m plus n, isn't it? Now, again, if you observe this, you can directly find out the derivative. But if you take log both sides, it is better for us, isn't it? So that the function gets simplified and you can easily find out the derivative, right? So, taking log both sides, log of x raised to m, y raised to m is equal to log of x plus y whole to the power m plus n, isn't it? Now, here, this is AB, means this is the multiplication of a two term. Therefore, the log AB, it is nothing but log of A plus log of B. Here, log of x to the power m, log of y to the power n. This power you can multiply here, m plus n, log of x plus y. Here again, m log x, n log y. Here, m plus n into log of x plus y. Right? Now, m remain as it is. The derivative of a log x, that is 1 by x. N remain as it is. The derivative of a log y, that is 1 by y, into dy by dx. When the constant, again it is multiplied to the function, constant remain as it is. The derivative of a log of x plus y, again apply the chain rule. Here you have to substitute u. The derivative of a log u, that is 1 by u, means 1 upon x plus y. Again the derivative of a x, that is 1, and this is dy by dx. Right? Now open the bracket and here collect the terms of dy by dx. M by x plus n by y into dy by dx. It is equal to m plus n divided by x plus y plus m plus n divided by x plus y into dy by dx. Right? Now collect the terms here. N by y minus m plus n divided by x plus y into dy by dx. Here again m plus n divided by x plus y, right, minus m divided by x. Right? Now you can cross multiply it here. The cross multiplication, n into nx plus ny, right? Nx plus ny. Now here you can multiply with minus y, that is minus my and minus ny divided by y x plus y and into dy by dx. Again, this is equal to, see here, here also you can make the cross multiplication mx plus nx, again multiply with minus n, minus mx minus my divided by again x plus y, right, into x. Again, if you observe this denominator get cancelled. Here the term ny get cancelled. Here the term mx get cancelled. What is remain here? See, I rub this problem here. That is, what is the term here you have got? That is nx minus my divided by y into dy by dx. It is equal to nx minus my divided by x. Right. Again, if you observe this, nx minus my get cancelled, and here you have got dy by dx, it is equal to y by x. So, this is the result. And this is again the very, very important result, right? So, we have taken log both sides. Because of the log, the function gets simplified, and it is better to find out the derivative easily, isn't it? So, log of AB means log of A plus log of B. Here this power comes multiplied here, m plus n into log of x plus y. Again, m remain as it, m log x plus n log y, and this is differentiate. M remain as it is, the derivative of a log x 1 by x, n remain as it is, the derivative of a log y 1 by y into dy by dx. When the constant, it is multiplied to the function, again the constant remain as it is, the derivative, here you have to apply chain rule, the u you have to substitute, the derivative of a log u, that is 1 by u, means 1 upon x plus y, the derivative of a x1 plus the derivative of a y, that is dy by dx, right? Again you have to multiply to this bracket and simplify the bracket, collect the terms of dy by dx, and you will get the result, isn't it? So this is the 9th bunch, right? Again, right? 10th one. Here see, observe, cos inverse of x square plus y square divided by x square minus y square. It is equal to, suppose, alpha. This is first. Second, sec inverse x cube minus y cube divided by x cube plus y cube. It is equal to tan alpha. Third, log of x square plus y square divided by x square minus y square. It is ten. Fourth one, suppose tan inverse tan of x plus y divided by x minus y. It is equal to sec beta, right? And the fifth one, again you can take here, that is the cosec inverse x square minus y square divided by x square plus y square. It is equal to, suppose, beta. Now again, if you observe this problem here, that is the 10th one. The right hand side, it is entirely in the form of what here, constant, alpha constant, tan alpha constant, tan constant, sec beta constant, and what here beta constant, right? Now see what you have to do here. Here, since this is the constant, and here also you have got the result, that is dy by dx, it is equal to y by x. Right? The result of this all 5 questions, here you have got y by x. Now see the first question, cos inverse x square plus y square divided by x square minus y square. It is equal to alpha. Now you can write x square plus y square divided by x square minus y square. it is equal to cos alpha. Right? So that cos alpha you can consider as a constant and write the constant k, where k is the constant. Isn't it? Now here what you have to do, x square plus y square divided by x square minus y square, you can write as a k into x square minus y square. Isn't it? Now here you have got, that is x square plus y square, here kx square minus ky square. Right? Now y square plus ky square, and here kx square minus x square. Right? Now 1 plus k as it is, and you can take y square common. Here you can take x square common, k minus 1. Therefore y square divided by x square is equal to k minus 1 divided by k plus 1. Isn't it? Now this is 1 and this is 2. Here you have to differentiate 1 and then you have to substitute the value of a k minus 1 divided by k plus 1. Right? So differentiate 1. Second ला differentiate करू नका, differentiate first. इसको differentiate करना first को, second को नहीं. Differentiate 1 with respect to x. Isn't it? Again 1 plus k. Constant remain as it is. The derivative of a y square, that is 2y dy by dx. Here again k minus 1. Constant term remain as it is, and the derivative of a x square, that is equal to 2x. Right? Therefore dy by dx, it is equal to that is 2x. Here again k minus 1 divided by 2y k plus 1. Isn't it? Now 2 get cancelled. Here you can substitute the value, that is k minus 1 divided by k plus 1. It is nothing but y square divided by x square. See? Right? Again y get cancelled. X get cancelled. Here you have got y by x. Right? So the result, that is y by x. But whenever you have to show, you have to prove that sometimes there is an inclusion of a alpha. Isn't it? Whenever there is an inclusion of a alpha in the prove that or show that, then what you have to do, directly you have to consider cos alpha, don't take k. Isn't it? So here see the result again. By taking the cos alpha as it is, again x square plus y square. Here you can write, that is x square cos alpha minus y square cos alpha. Isn't it? Now again if you transfer this, here you have got c, that is the y square you can take common, 1 minus cos alpha, and here x square you can take common, cos alpha minus 1. Isn't it? Therefore here see the result, that is, now you can differentiate. Isn't it? Now you can collect the terms like this, x square, here you can transfer, this is y square. Therefore here you have got 1 plus, if you transfer this is minus y square cos alpha to this side, then it becomes plus. Therefore y square you can take common, 1 plus cos alpha, and x square you can transfer that side here. Therefore cos alpha minus 1. Again differentiate. 1 plus cos alpha remain as it is. The derivative of a y square, that is 2y dy by dx. Cos alpha minus 1 remain as it is, and the derivative of x square, that is 2x. Isn't it? Now see here, you have got the dy by dx. It is nothing but cos alpha minus 1 into 2x divided by 1 plus cos alpha into 2. Again 2 get cancelled. Here you have got, if you take minus sign common, 1 minus cos alpha divided by 1 plus cos alpha, and this is x by y. Right? Again you can write the evergreen formula, 1 minus cos alpha you can write as a 2 sine square alpha by 2, and here 2 cos square alpha by 2, x by y. 2 get cancelled. Here you have got the result, that is minus x by y into tan square alpha by 2. Right? This is also the another result. Right? Whenever there is an inclusion of a cos alpha, no need to write what here k, but whenever the result, suppose this result is not given, the result is given in the MCQ, that is y by x, then directly you have to take what here k here. So there are again the two results, with inclusion of a alpha, and you can in place of cos alpha, you can take the k, isn't it? So here you have got the 10th bunch. Suppose I take another example here again. I will take one more example. See, that is log of x square plus y square divided by x square minus y square to the base 2, and here 10. Now you know the laws of logarithm. Log of a to the base b, you can write as a log of a divided by log of b. Right? Suppose you write like this here. That is log of x square plus y square divided by x square minus y square divided by log 2. It is equal to 10, isn't it? Therefore here now you can take the base as a 10 and this is 2. Suppose the base is 10 and suppose this is 2. Then again the base is 10 and this is whatever. See, I will change the problem. I have taken the base as a 10, right? And here that is 2. See, what will you get here? That is the log of x square plus y square divided by x square minus y square. It is equal to 2 log 10, isn't it? And here log of x square plus y square divided by x square minus y square is equal to log of 10 square, that is nothing but what is 100. Now you can cancel log both sides, and again here you have got that is x square plus y square. It is equal to 100x square minus 100y square. 100y square. Right. Now this 100y square you can transfer here. Y square plus 100y square, that is 101 y square, and 100x square minus x square, that is 99x square. Now you can differentiate with respect to x, isn't it? Therefore 10 remain as it is. The derivative of a y square, that is 2y dy by dx. Here again 99 remain as it is. The derivative of a x square, that is 2x. 2 to get cancelled. Here you have got that is dy by dx. It is equal to 99x divided by 101, isn't it? So this is the result, right? So log of x square plus y square divided by x square minus y square, I have taken as a, means the base is given. Suppose you write directly this is k, then also it is possible. This you can write as a, considered as a k, then you have got the result, that is dy by dx, it is equal to y by x, right? But sometimes they ask, prove that, show that, that time you have to write like this, isn't it? You have to do the problem like this. Whenever you have to show, whenever you have to prove something. Otherwise, suppose you consider k, then you will get the result, that is what here, that is y by x, isn't it? Now this you can write as a, say, log of x square plus y square divided by, that is x square minus y square. It is equal to, that is what here, log of 100, and the 100 you can write as a k, log of 100, and x square plus y square divided by x square minus y square, or this you can write as a, suppose c or any constant, and this is c here. This again log get cancel here, and the 100 you can consider c, x square plus y square divided by x square minus y square. 100 you can consider it as a k, and do the problem, you will get the result, that is what here, y by x. But whenever you have to prove something, you have to write like this, isn't it? So here we have used the laws of logarithm. Log a to the base b, we have wrote as a log of a divided by log of b. We have multiplied here. Again, log 2 log 10, it is nothing but log of 100. Log get cancelled, and again 100 you multiplied there, and you will get the result, isn't it? So this is about the 10th bunch. Now the 11th, see, that is root of 1 minus x square plus root of 1 minus y square. It is equal to a x minus root of 1 minus x to the power 4, root of 1 minus y to the power 4. You can write as a x square minus x square, and again root of 1 minus x to the power 6, root of 1 minus y to the power 6. You can write as a x cube minus y, isn't it? Now the result of the first question, that is the answer, that is dy by dx, it is equal to root of 1 minus y square divided by root of 1 minus x square. The second one is dy by dx. It is nothing but here, that is x root of 1 minus y to the power 4 and y root of 1 minus x to the power 4. And the third is dy by dx. Here you have got x square root of 1 minus y to the power 6 divided by y square root of 1 minus x to the power 6. This is the result of this question here. So, write down this. Again the three examples, again very important, again the bunch, isn't it? But it is little bit lengthy and little bit different. You can't, you can differentiate directly also, but whenever you differentiate directly, you will get the another result and don't get this result, right? Now by doing the procedure like this, now here you have to substitute both. X is equal to sine theta and y is equal to sine phi. Right? Now substitute here root of 1 minus sine square theta, first problem, plus root of 1 minus sine square phi. Here you have got a x is equal to sine theta minus sine phi. Right? Now 1 minus sine square theta, that is cos square theta, and the square root of a cos square theta, that is equal to cos theta. Here again 1 minus sine square phi, cos square phi, the square root of a cos square phi, that is cos phi. Here a sine theta minus sine phi. Right? Now again you have to use the formula cos a plus cos b. What is the formula of a cos a plus cos b? That is 2 cos a plus b divided by 2 cos a minus b divided by 2 is equal to, again you have to apply the formula of a sin a minus sin b. What is the formula of a sin a minus sin b? 2 cos a plus b divided by 2 sin a minus b divided by 2. 2 cos a plus b means theta plus phi divided by 2 sin theta minus phi divided by 2. Right? Again if you observe this, 2 get cancelled and this term also get cancelled. You have got cos theta minus phi divided by 2 divided by sin theta minus phi divided by 2. It is equal to a. Therefore, cos by sin, it is nothing but what here cot theta minus phi divided by 2. It is equal to a. Therefore, theta minus phi divided by 2. It is equal to cot inverse of a, and theta minus phi, it is equal to 2 cot inverse of a. But see, what is theta? The theta, it is nothing but sine inverse of x. Right? And the phi, it is nothing but sine inverse of phi. It is equal to 2 cot inverse of a. Now differentiate. The derivative of a sine inverse is 1 upon root of 1 minus x square. The derivative of a sine inverse phi, root of 1 minus y square into dy by dx. And here the derivative, it is equal to 0, isn't it? Therefore, here you have got root of 1 minus x square is equal to 1 upon root of 1 minus y square into dy by dx. Therefore, here you have got, that is the dy by dx is equal to root of 1 minus y square divided by root of 1 minus x square. This is about this bunch here, that is the 11th bunch. The 3 problem I have given. The proof is like this, isn't it? Always ask, that is dy by, show that dy by dx is equal to this, right? Now the simple here, this you can write as a, in place of x to the power 4, you can write x square whole square, here also x square whole square. And instead of substituting x is equal to sin theta, Suppose you put x square is equal to sin theta and y square is equal to sin theta. Here you have got CN, x square and y square, right? Now let's see the result here. Again, see the result. Sin inverse x square, the derivative of sin inverse x square 1 upon root of 1 minus x to the power 4. The derivative of x square, that is 2x, 1 upon root of 1 minus y to the power 4. This is 2y dy by dx. Here again this is equal to 0. Therefore 2x root of 1 minus x to the power 4 is equal to 2y root of 1 minus y to the power 4 into dy by dx. Right? Again 2 to get cancelled. X root of 1 minus y to the power 4 divided by y root of 1 minus x to the power 4. It is equal to dy by dx. See the result here. See the second result, isn't it? So in this way you can do the problem, isn't it? So here you have to substitute x is equal to sin theta and y is equal to sin psi, right? Now another method I will do directly. Suppose you directly do. See what is the result again. Very simple. We will get the different results here, right? In implicit function. Again, whenever the result is not got, then you have to manage the problem, isn't it? No, direct differentiate with respect to x. Here, the derivative of a root of 1 minus x square, 1 upon root of 1 minus x square, right? And the derivative of a minus x square, that is equal to minus 2x. Again, 1 upon 2 root of 1 minus y square. The derivative of a minus y square, that is minus 2y into dy by dx. A remain as it is. The derivative of a x1 and the derivative of a y, that is dy by dx. 2 to get cancelled, right? This 2 also get cancelled, right? This is the root u, the derivative of a root u, 1 upon 2 root u, 2 to get cancelled. Here, suppose I multiply with minus sign, then you have got x divided by 1 minus x square plus y divided by root of 1 minus y square into dy by dx, and here you have got minus a and minus minus plus, because I have multiplied with minus sign, minus a and minus minus plus a dy by dx, isn't it? Now collect the terms of dy by dx. Y divided by root of 1 minus y square minus a into dy by dx. Here again minus a and minus x root of 1 minus x square. Right? By cross multiplication, y minus a root of 1 minus y square divided by root of 1 minus y square into dy by dx. Here again minus sign remain as it is. Here a root of 1 minus x square plus x divided by root of 1 minus x square. Right? So dy by dx, again by cross multiplication, see here, this term goes here, minus sign remain as it is. Here root of 1 minus y square in bracket a root of 1 minus x square plus x divided by root of 1 minus x square. Here again y minus a root of 1 minus y square. This is the another result, isn't it? So if you do directly, you will get that result. And if when you substitute x is equal to sin theta and y is equal to sin phi, you have got the result root of 1 minus y square divided by root of 1 minus x square. Right? Now some tricky examples are also there. See. Again, e raised to x is equal to x raised to y. Second, e raised to y is equal to y raised to x. Third, e raised to x is equal to x to the power y is equal to e raised to x minus y, isn't it? And the fourth example, x raised to y is equal to y raised to x, isn't it? Now these are the four tricky examples here. E raised to x is equal to x raised to y. Again, if you observe this, when one function is the power of another, you have to take log both sides. Log of e raised to x is equal to log of x raised to y, isn't it? Now see, here again x. The value of a log e, that is equal to 1. Here y log x. Now, you can direct differentiate, but this you can convert into an explicit form. This function you can convert into the explicit form because y you can write as x divided by log x, isn't it? Now you can differentiate directly by the division rule, dy by dx, it is equal to log x remain as it is. The derivative of x1 minus x remain as it is. The derivative of a log x, that is 1 by x divided by log x whole square. X get cancelled. Here you have got log x minus 1 divided by log x whole square. This is the first result, isn't it? Now suppose you can't convert into the explicit form, then see what is the result. X is equal to y log x. Direct differentiate with respect to x. See, the derivative of x1, here you can apply multiplication rule, y remain as it is. The derivative of a log x 1 by x, log x remain as it is. The derivative of a y, that is dy by dx, isn't it? Now you can transfer this 1 minus y by x. It is equal to log x dy by dx. This you can write as x minus y divided by x is equal to log x into dy by dx. And here x minus y divided by x log x, it is dy by dx. This is also the second result. But again from this you want the same result, right? From this result, again you want this result, then what you have to do? See, what is the value of x? That is y log x. This value you have to substitute here. What is the value of x? Y log x. You can substitute here y log x minus y. Here again y log x. In place of x you can substitute y log x, and this log x remain as it is. This is equal to dy by dx. See, y you can take common. Log x minus y. Here y and log x whole square. It is equal to dy by dx. Again y get cancelled. Here you have got the result, right? By seeing when you got this result, then you have to manage the problem by substituting x is equal to y log x to get this result. Suppose the question asked, prove that, show that, that is log x minus 1 divided by log x whole square, then this result you have to manage like this. तर हा रिझल्ट तुम्हाला या पद्धतीने मॅनेज करावा लागेल. इम्प्लिसिट फंक्शनमध्ये यू विल गेट द आन्सर इट सेल्फ इन द प्रॉब्लेम, इजंट इट? सो these are the tricky example. You can convert in the explicit form. तुम्ही एक्सप्लिसिट फॉर्ममध्ये कन्वर्ट करून करू शकता, कारण शो दॅट प्रूव्ह दॅट असेल की हा रिझल्ट असतो. अँड इफ द सिम्पल whenever you want to find out, only suppose they have asked find dy by dx, then this also result you can write. That is dy by dx is equal to x minus y divided by x log x, right? Because they do not ask you that is this result, that is show that, right? So you can write any results here. So in this way you can do the implicit derivative of a implicit function. Again tricky example, second one here, e raised to y is equal to y raised to x, right? Again you have to take log both sides, because when one function is the power of another, you have to take log both sides. Again y log e, that is nothing but 1, x log of y. Again you can convert in which form here? That is the explicit form, y divided by log y, it is equal to x. Now x is the function of a y, you can differentiate with respect to y, that is dx divided by dy. Again apply division rule, log y remain as it is. The derivative of a y 1 minus y remain as it is. The derivative of a log y 1 by y, because you are going to differentiate with respect to y, therefore here again log y whole square. Y get cancelled. Log y minus 1 divided by log y whole square. But what do you want? We want dy by dx. Therefore dy by dx, it is nothing but 1 upon dx divided by dy, that we have done in what here? That is the inverse theorem, isn't it? There we have studied dy by dx is equal to 1 upon dx divided by dy. Therefore 1 upon dx divided by dy means log y minus 1 divided by log y whole square, and this you can write as a log y whole square divided by log y minus 1. So this is about the second problem. Right? Again the third one, very important, that is x raised to y is equal to e to the power x minus 1. Again one function is the power of another. You can take log both sides, isn't it? Suppose you take log both sides, log of x raised to y, log of e raised to x minus 1. Right? Again y log x. Here x minus 1, you can multiply it here. The value of a log e, that is equal to 1. Now this minus y you can transfer here, y log x plus y, it is equal to x. Again y you can take common, log x plus 1, it is equal to x. Therefore y is equal to x divided by 1 plus log x. Again the problem you have converted in which form here? Explicit form. Now directly you can apply the division rule and find out the derivative, dy by dx. The denominator remain as it is, 1 plus log x. The derivative of a x1 minus x remain as it is. The derivative of a 1 0 and the derivative of a log x, that is 1 by x divided by 1 plus log x whole square. Right? Now dy by dx, it is equal to, this is x get cancelled, 1 plus log x minus 1 divided by 1 plus log x whole square. Now minus 1 plus 1 get cancelled, log x divided by 1 plus log x whole square. This is the result, isn't it? And the last, that is fourth. Fourth, x raised to y is equal to y raised to x. Again one function is the power of another, you can take log both sides, log of y raised to x, y log x, x log y. Right? Now y remain as it is. The derivative of a log x 1 by x plus log x remain as it is. The derivative of a y dy by dx. Here again apply multiplication rule. X remain as it is. The derivative of a log y 1 by y into dy by dx plus log y remain as it is. The derivative of a xy. Collect the terms of dy by dx, log x minus x by y into dy by dx. It is equal to log y minus y by x, isn't it? Now y log x minus x divided by y dy by dx. Again x log y minus y divided by x. Right? Therefore here you have got dy by dx, it is y into x log y minus y, and here again x y log x minus x, isn't it? So this is about the fourth one. Again I will take the two more problem, right? So the one thing I want to tell you that you have to do all the problem in the exercise, and also you have to do the miscellaneous, every problem of the miscellaneous that is asked in the CET, because the CET level, it is on the ground of what here? JE level. They have updated, that is the CET level into what here? JEE level. Therefore, it is very necessary to do the problem of the miscellaneous. Always they ask the problem in the miscellaneous, right? That is little bit difficult, but you have to attain, you have to solve each and every problem. Also the MCQs in the textbook. Right? Don't forget about the textbook, because the textbook are the best guide for you, and that is prescribed by the board. Therefore, it is, you have to focus on the board, the every problem on the board. Then you will get the good result in the CET as well as the JE also. Right? Once you know the basic thing, you can deal with the any problem. You can solve the any problem, isn't it? That is the problem of a JE and the problem of the CET also. So again I will take two more problems. See. here, that is log of x plus y minus log of x y, it is equal to suppose a. Right? Now again there are the two results. See, the one result, that is the dy by dx, I think so, y square divided by x square. See the two results here. Again this you can write as a, suppose you differentiate, it is little bit difficult. Therefore log a minus log b you can write as a log of a by b, means log of x plus y divided by x minus y, it is equal to a, isn't it? Now x plus y divided by xy, it is equal to log inverse. Log inverse, it is nothing but what? E raised to a. Now from this, see, this is one. Separate divide, x divided by x by y means 1 by y, and y divided by x by y means 1 by x. It is equal to e raised to a. Now differentiate with respect to x, isn't it? The derivative of a 1 by y, that is minus 1 upon y square into dy by dx, and here the derivative of it is, that is minus 1 upon x square, and the derivative of a e raised to a, it is equal to 0 because it is independent of x. Now this you can write as a, suppose minus 1 upon x square, it is equal to 1 upon y square into dy by dx, isn't it? That is minus 1 upon x square remain at this side and transfer this. Again you have got the result, that is y square divided by x square, it is equal to dy by dx. Now this is one of the result. But suppose again there is an inclusion of this constant, that is e to the power a, then see the result here, that is x plus y, inclusion of this, that is xy into e to the power a. Now differentiate with respect to x, the derivative of xy, the derivative of a y dy by dx, e raised to a constant, when multiplied to the function, constant remain as it is, apply multiplication rule, x remain as it is, derivative of a y dy by dx, y remain as it is, the derivative of a x, it is equal to 1 plus dy by dx, again multiplied x into e to the power a into dy by dx plus y into e raised to a. Now collect the terms here, the coefficient of dy by dx 1 and the coefficient of dy by dx x into e to the power a, transfer this side and write the multiple dy by dx, it is equal to y into e to the power a minus 1, right? Therefore dy divided by dx, here you have got this y into e to the power a minus 1 divided by 1 minus x into e to the power. This is again the second result of this problem, isn't it? Again I will take one more problem, some unusual, that is y root of 1 plus x plus x root of 1 plus y, it is equal to 0 where x not equal to, right? See the result here. Suppose you directly do, then you will not get the result like this. They ask sometimes, that is prove that, I think so, dy by dx, it is equal to minus 1 upon x plus 1 whole square, like this. Right? So there should be little bit difference also, but the result is like this, that is prove that. PT means what here? Prove that. Now for this purpose, whenever you have to show dy by dx is equal to this, then what you have to do? You can't do directly, that is you can't differentiate directly, that is y into root of 1 plus x into root of 1 plus y, it is equal to 0, right? You can't differentiate. Now see, to get this result, see what you have to do, y into root of 1 plus x is equal to minus x root of 1 plus y. Now what you have to do, squaring both sides, isn't it? Now if you make the square, you will get y square, again 1 plus x, here x square, 1 plus y, right? Now y square, xy square, again x square y, right? Now see what you have to do, again transfer x square minus y square, again x square y minus xy square, it is equal to 0. Again if you observe this, here x square minus y square, you can find out the factor that is x minus y and x plus y. Here again you can take xy common. What is remain? X minus y is equal to 0. From this whole function, you can take x minus y common, and what is remain here, say x plus y plus xy, right? It is equal to 0. But the condition they have given that x not equal to y means x minus y cannot be equal to 0. Therefore, x minus y cannot be equal to 0. Therefore, since this bracket it is not equal to 0, therefore you have to consider x plus y plus xy, it is equal to 0. Again x, you can take y common, 1 plus x, it is equal to 0. Again y into 1 plus x, it is equal to minus x. Therefore, y is equal to minus x divided by 1 plus x. Isn't it? Now, this is the simplification of a problem. Now, you have to differentiate. Suppose you do directly, you will not get this result here. Now, dy by dx, it is equal to, this minus sign remain as it is. Apply division rule. 1 plus x remain as it is. The derivative of x1 minus x remain as it is. The derivative of a 1, 0. The derivative of a x1 divided by 1 plus x whole square. Right? Now again plus x minus x get cancelled. Here plus x minus x get cancelled. 1 divided by 1 plus x whole square. See, this is the result, isn't it? So this is about the implicit, and here in a 2 parts I have completed the derivative of a implicit function. Now the next function, that is the derivative of a parametric function, isn't it? So we have to see in the next video. These are the very implicit function. It is very important, and I have given the lot of bunches also and the unusual problem also, right? So please, the student, if you like my video, then share it and subscribe my channel. Good day for you.